All right, so today is Wednesday, December 11th, 12/11, and I have the wrong date on the board. Let me go fix that. For some reason, I changed that to 12. Or changed it twice. All right, now the correct day is on the board. We are on lesson 5-8, System of Equation Word Problems. It's our last lesson of the semester, last lesson of the quarter, last lesson before we start reviewing for finals. So, who can read our objective? Charles. Oh wait, Charles, you don't have your card. Let's go with Emma.
Create and then solve a system of linear equations from a real life problem.
Thank you. And Eamon, can you please shut your laptop? All right, so example 1, Ugo or Esha, does either of you want to read? It's about you.
I can.
Go for it, Esha.
Ugo is 4 years older than Esha. 3 years ago, Ugo was twice as old as Esha. How old is Ugo?
All right, so that seems kind of confusing. You could always do guess and check and be like, okay, maybe Ugo is 5 and Esha is 1, because that's 4 years older. But then guessing and checking is going to take us a really, really long time. So the general idea for every single one of these problems, all the way through example 5, is set up two equations. I mean, it's going to be a system of linear equations. So if you set up your two equations and then solve using either substitution or elimination, or if you're old school, you can do graphing, then we'll be done. All right, so who wants to take a shot at setting up one of the two equations? What?
So can I use the variable h for Ugo and the variable e for Esha?
All right, lowercase or capital?
Lowercase is
Okay.
fine. H equals e plus 4.
There's our first equation. Ugo is 4 years older than Esha. Perfect, thank you. Who can set up another equation? Kira.
H times 2 equals e minus 3.
You're really, really close. So you said h times 2 equals e minus 3, right?
Yeah. Or h times 2e minus 3. I don't know.
2e. Yeah, so this one is actually really hard, and I kind of feel bad for not talking about it. Yeah, give it a shot, Charles. You still get your XP, Kira, so thank you.
I think it's e times e plus, wait, e times 2 equals h.
Close. So this doesn't account for the fact
Or
that
e
this
plus
was
4.
3 years ago. We haven't taken this 3 years ago into account. Because if it was 3 years ago or 4 years ago, it does make a difference.
Ooh.
Let's go back with Kira again.
Do you go like -3 and then in parentheses h times 2 equals e?
H minus 2 is equal to e, like that?
Times 2.
Oh, h times 2 minus e. You're close, but you're still not quite there. Wyatt, you want to give it a shot?
Would it be in parentheses e minus 3 and then outside of the parentheses 2?
Right here, 2?
No, behind it.
2?
So you do it after.
Okay.
You do the parentheses and then you're gonna do equals and then another parentheses h minus 3.
That is the correct equation, yeah. So, let me help by stating this. If I say e, that is Esha's age. If I say e minus 3, that is Esha's age 3 years ago. So this is Esha's age 3 years ago. This is Ugo's age 3 years ago. And now we're saying 3 years ago, Ugo is twice as old as Esha. So whenever you have something that says 3 years ago or some distance in the past, both of your variables will need to be subtracted by however long ago it was. Yeah, thank you, Wyatt.
Of course.
I need someone else to solve now. I have two equations, a system of linear equations. I can help you guys a little bit. I can change this bottom equation. I can distribute this 2 into both of these two terms. So it becomes 2e minus 6 is equal to h minus 3. Again, just distributing that 2. So now I'm looking at this blue equation and this green equation. I guess I can zoom in, so that's all I really need to look at. The blue equation and the green equation. You can either use substitution or elimination. If you want to be old school, you can do graphs, but I would prefer substitution and elimination. Does anyone see how you could use either substitution or elimination to solve this? I see 2 people have an idea. I need more people, though. You do have a mouse. I now have 3 people, but it's kind of the same 3 people that's been participating over and over again. Everything you have. Okay, we'll go with Kira.
Okay. Could you add 6 to 3?
Add 6 to both sides, yeah? Okay, so if I do that, I now get 2e is equal to h what?
H plus 3.
Okay. So that's a good first step because you're just kind of getting the constants on one side. Who has another step? We'll go with Charles.
Wouldn't you subtract a 3 to make the h like be alone, like on the top equation?
So on this blue equation right here,
Yeah.
you want to subtract 3?
Yeah. Aren't we trying to get h by itself?
We're trying to somehow combine the equations with substitution or elimination, I think is the goal here. Because right now we have 2 variables.
Okay, so we
I
can
think mine's
divide
over here.
2.
I think mine's exploding over here.
Okay.
Wait, so we're trying to get is there one variable?
Yeah, we're trying to get it so that there's one variable. Right now we have the problem that we have an e and an h and an e and an h. Somehow I can use either elimination or substitution to combine those 2 equations.
Look, I have a card.
We have to. We have to get the h to the other side. On the top equation.
So we'll go with Larissa. Sorry, what? We need to get more people in.
Wouldn't you like do the 0 thing and stuff like that now?
So the 0 thing is whenever we're trying to graph something that's in standard form, when we're trying to find the x or the y intercepts. But somehow I need to use either substitution or elimination. You want to call in someone?
Wyatt, I guess.
Yes. Okay.
Really, that is cool.
Okay. To use substitution, we already know what h is equal to based on the first equation because it's really saying h is equal to that. So we can just plug in e plus 4 into the h variable. So we only have one variable in that equation.
Exactly. So you guys can circle this e plus 4. That's h. This e plus 4 is h. That's how you read it. And you can draw an arrow and saying, hey, that's going to go right there. All right, so Wyatt, can you read our equation after we do that substitution?
Of course. 2e is equal to, in parentheses, e plus 4 plus 3.
Thank you. Yeah.
Because we substituted the e plus 4 and so we have to put it in.
Yes, always use parentheses when you do substitution. It will make sure that if you accidentally have to, or if you have to distribute a negative or something, that won't confuse anyone. All right, and we have hit the goal. Again, our goal that we've been talking about over and over again is we need to get some equation with one variable. We have only one variable, e, no other variable, everything else is a constant. So we've achieved our goal, and now we can solve for e, and that's going to be Esh's age, which is going to be good, but we're going to have to find Ugo's age eventually. So I need someone else now to help me solve. Preferably someone that has their card. Charles?
Would you divide 2 from e on each side?
So divide both sides by 2?
Yeah.
You could do that. I think we should probably get our e's on both sides, or on one side. So, okay, let's subtract e on both sides. You can kind of drop the parentheses at this point because nothing is being multiplied by this. If things were being multiplied, we'd have to distribute. So you can kind of ignore the parentheses and let's subtract e on both sides. Okay, Charles, read our new equation, please.
E equals 4 plus.
And you can simplify 4 plus 3 for us as well, right?
Probably 7.
What is 4 plus 3?
7.
All right, so that's not the answer. I'm not going to box that. That's Esh's age. So now somehow we need to go back and say, how old is Ugo? That's the original question, right? So what do I do now that I know that e is equal to 7? Ulysses, you have your card, right?
Yeah.
Yeah, go for it, Ulysses.
So wouldn't you like add 4 to 7?
Why are you adding 4 to 7? You're correct, but why?
Because like is it Ugo is 40 years older than I should?
Oh yeah, so using this sentence here, and that's kind of using this equation too, right?
Yeah.
Yeah, okay, so we're basically plugging into this first equation. So h is equal to 7 plus 4. I guess I'm substituting that 7, so keep the parentheses on it. And therefore, Ulysses, Ugo is how old?
11.
There it is. Ugo is 11 years old. Thank you. All right, so reviewing the process. We set up two equations from our word problem, and then we used either, in this case we used substitution, but you could have used elimination as well to solve for one variable, and then we had to plug it back in to solve for the one that we were actually trying to find. Does anyone have a question about example number 1? Charles?
No.
Does anyone have a question about number 1? Asha? Yeah.
So our answer would be, would it be E equals 7 and H equals 11?
So the question isn't asking how old Esha is, it's only asking how old Ugo is. So how old is Ugo? So that's why we kind of ignored the fact that Esha was 7 years old. All right, we're on to example number 2. Do you want to read it for us, Charles?
I'm just gonna do it.
You can read it for us too.
I could read it.
Oh, how's it hard to
Okay.
I had it.
Eamon, can you read it for us, please?
In 42 years, Haziel will be 4 times as old as he is right now. How old is he right now?
Yeah, so somehow we're going to have to, thank you, somehow we're going to have to get 2 equations from that. Almost. So, I need you guys to put on your thingy caps. What are the 2 equations? Or give me one of the equations.
I didn't use the equation.
Oh, you just know it? Nice. So how did you figure it out, guessing and checking?
4 divided by 42.
4 divided by 42 is a...
42 divided by 4.
Oh, 42 divided by 4.
Or 42 divided by a fourth.
42, what is 42 divided by 4?
10 and a half.
So he's 10 and a half years old? Okay, so we'll write down maybe that is the answer. 10.5. So I'm looking for a quiet raised hand. Who can figure out one of the equations? Kira?
Well, I just did this because Haziel's 14 and 14 times 4 is a 56 and 42 plus 14 equals 56. So I think.
Oh, so you're giving us another answer. So what was your answer? How old is he right now? 14? Okay, so now we have 2 possible answers. Interesting. Wyatt?
I think I might have an equation.
All right, let's see it.
So using the variable j for Haziel, I think j. So I think j is representing that Haziel's age right now.
Okay.
And j plus 42 is still equal to j times 4 because in 4 years in 42 years he'll be 4 times as old as he is right now.
I'm gonna write that as 4j. Okay, so you've not only written the 2 equations, but you've already set them equal to each other.
Really?
Yeah, so that's
Wait,
it.
was one of the equations j times 4 equals 42?
J times 4 is equal to 42, and that's not quite right, no, because you have to somehow add the 42 on.
I can't believe I just did that.
Okay, so Wyatt set up the equation for us. Let's go ahead and solve.
Okay.
But I guess before we solve, I guess I should make sure we know what's going on. We're saying, again, Haziel is his age is represented by J. So in 42 years, so the age plus 42, that's saying in 42, then we know that we're just multiplying 4 times as old as he is right now. So J represents how old he is right now. So 4 times that is just 4J. Hopefully no one has, well, if anyone has questions, now's the time.
Can we solve?
Yes, let's solve. Who's gonna do it?
I can't.
I want to get more people to volunteer too. Yeah, Esha, I haven't heard from you in a while.
We could, so we're trying to get all the j's on the other side of the equal sign?
Yes.
So we could subtract j on both sides.
Okay, what do we get when we do that?
4. Because
so those
4j
j's
minus j.
minus 1J, right?
Oh. Well, so 3j?
3J on the right-hand side, and then on the left-hand side I have...
42.
Perfect. You want to keep going or turn it over to someone else?
I can keep going.
All right, so what are you going to do next?
Divide 3 on both sides.
Yep. And that leaves you with what?
Well, I don't know what 42 divided by 3 is, so.
It's one of the answers that we have written up here.
Oh. Is it 14?
It is indeed 14.
So
Kira was right.
14 equals j.
There it is. Haziel's 14 years old right now.
Kira was right.
Yeah, good job, Kira.
work.
Yeah, you don't always need to use an equation to solve it. If you can find it by guessing and checking, that's a perfectly valid strategy. I just want to make sure that we know how to use equations just in case you can't figure it out by guessing and checking. All right, we have a few more examples. Example number 3. Ulysses, do you want to read yourself? Or maybe Emma? I don't know who wants to do it. All right, Ulysses, go for it.
Ulysses is 27 years old and Emma is 3 years old. How many years will it take Ulysses until he is only 4 times as old as him?
All right, so right now Ulysses is definitely over 4 times as old.
He's almost, he's like,
He's 9 times as old, right?
in one more year he'll be like 7 times as old.
This is not possible because they're both kind of aging. They're always gonna have the same amount of years.
Okay, so it might not be possible. The answer might be no solutions, right? And if we get no solutions, we're looking for something of like the form 1 equals 0, right? So if we get that, then that confirms Kira's theory, right? All right. So, yeah, Wyatt, talk to us.
Okay, I would put 27 over 3. This is the long way to do it. I don't know the algebraic. But if you put 27 over 3, and then you just add 1 every time, eventually you'll get Ulysses at a certain age.
You are 100% correct.
No, I don't
That's
know
exactly
how to do
what
it.
I just did.
Yeah, I just.
So then I can change this problem to make it that Ulysses is 1,000 years old and Emma is 3 years old. How long will it take to be 4 times as old? So it makes it so that it'll take you roughly
It couldn't
20
be
minutes to do
1,000
this problem that way.
It couldn't be 1,000 over 3 though.
Yeah,
It'd
could.
have to be 1,000 over another number. You add 1 over 1. Because every year they will be coming across the board.
Yep, so 1,000 over 3 will eventually turn into the fraction 4 over 1. So I don't want to tie our hands like this, so I'm going to, it's awesome that you guys have that strategy to just keep going. Okay, we'll just add 1 to the top and bottom, 28 over 4, add 1, 29 over 5, and keep going and keep going. And eventually you'll get it, but I'm going to, I could make this, change this to 1,000, and you can still solve this. I can change this to 1,000,000, and you can still solve this algebraically, just as fast as you could do this simple problem. So how can you do this algebraically? There's 2 equations that can be set up. I'll tell you that much. Because all of today's lesson is a system of linear equations. Yes, Kira.
27 over 3 times 10 to the blank power.
10 to the x power, I guess.
You multiply it by a certain number of times. I don't know.
Not quite, but good guess. Charles?
Would you do 27 times 4 equals u times actually I have no idea.
Okay.
Staff and students, pardon the interruption, please. Seniors, I'm on now. That is all.
He's going Christmas tree hunting.
Okay. Wyatt, talk to us.
Because it's saying Ulysses is only 4 times as old as Emma, maybe E is equal to U times 4.
That's part of it, yeah. So I'm going to write out that part. U is equal to E times 4, right?
Yeah.
So we'll say 4 times E. This is really, really close. But this is now, it's very, very similar to number 1, but going the opposite direction. This one was subtracting 3 from both the ages. So now we're going to be adding some age that we don't know. So we're going to change out U and E because we know those ages, right?
Yeah.
So what is U? You going to go for it again?
So it'd be 27 is equal to 3 times 4. No, 4 times 3.
Yeah, 4 times 3. And again, now I need to multiply Ulysses, or not, I don't need to multiply. I need to add on some time. So I'm going to say x, or I can say t, some variable. So this is x many years after Ulysses is 27 years old, and this is going to be x many years after Emma is 3 years old. So this age and this age are kind of counting forwards. We're counting forwards from 27, we're counting forwards from 3, and we want to have this relationship where Ulysses is 4 times as old as Emma. Here, go.
Well, I'm just thinking 27 divided by 3. Like, right now he's 9 times as old as her, so how could he ever be? Like, just what I said earlier doesn't.
Okay, yeah, I'll show you right now. Okay, so let's solve this really quick, and I'll show you another way to look at this. So I'm going to distribute the 4. Who can do that for us really quick? Emma?
So you do 4 times 3, which is 12 plus 4x.
12 plus 4x. Thank you. And then on the left-hand side, I still have 27 plus x. And then I need to solve again. Let's deal with those x's first. Who's got that? Larissa?
Subtract x.
Subtract x on both sides. What is our new equation when I do that?
27 equals 12 plus 3.
Perfect. And last step, who's got it? Esha?
Subtract 12 on both sides. And then you'll have 13, 15. Then you'll have 15 equals 3x. And then you divide 15 equals 3x. And then you divide 3 on both sides and you get x equals 5.
Hold on.
5 equals x.
Hold on. So we have the idea that he is that he is 7 times, that he is 9 times. So right now it's 9 times. But the way we just did it, it's 5 times. And in 1 year it's 7 times. So I guess.
It's going down and down, further and further, yeah. So the answer is, in 5 years, Ulysses will only be 4 times as old as Emma. And let me show you another way of doing this. So the answer was 5, and this is doing it algebraically. Let me show you the long way, kind of Wyatt's way, or everyone else's way of seeing this, which is, you're saying, okay, 27 over 3. So this is saying the fraction is 27 divided by 3, which currently is 9. 27 divided by 3 is 9. So right now we're saying Ulysses is 9 times as old as Emma. The next year, Ulysses is going to be 28, Emma is going to be 4. 28 divided by 4 isn't a nice... Oh, it's 7, right?
Yeah, 7.
Okay. And then I'm going to add on another year. 29 over 3. That's kind of a bad number. Let's keep going on. So 30 over 4.
Why would it be 29 over 3 be 5?
Oh, 5. My bad. Thank you. You can log the extra credit point.
I was like, what?
5.8. And then next we're going to have 30 over 6.
That's 5.
Which is 5. That's still not 4 times as old as Emma. And then the next one is going to be 31 over 7. 4.42. Kind of running out of room here. And then the next one is going to be 32 over 8. 32 divided by 8 is 4 times as old as Emma.
That's so.
And
Yes.
if you plug in 5 to x in the equation 27 plus x equals 4 times 3 plus x, it'd work out because it'd be 32 is equal to 32.
Yeah. Nice. It is indeed. All right. So
I honestly don't even know how to write a
my 32 over 8 disappeared. Why is this all messed up? That's why. 32 over 8. All right, so those are the age problems. Then you also have like the longer word problems in the back. Quiet raise hand to read. Emma.
Each chef at
Radical.
Radical Sushi prepares 10 regular rolls and 12 vegetarian rolls daily. On Tuesday, each customer ate 3 regular rolls and 4 vegetarian rolls. By the end of the day, 8 regular rolls and 4 vegetarian rolls remained uneaten. How many chefs and how many customers were in Radical Sushi on Tuesday? What?
This is a very confusing problem. I will acknowledge that.
The ones we do in first grade where it's like Sam had 6 more marbles than Katie who lost 3 marbles.
So, luckily, every single problem that I'm going to be giving you on Khan Academy has defined your variables. You don't need to be like, is my variables regular rolls, vegetarian rolls, chefs, customers, like number of leftovers, like it has defined it for you. It says, hey, your variables are going to be chefs and customers because those are the things that you're solving for. So we need to create a variable for chefs and customers. We can't use the letter C or the letter C because that's not going to be distinguished between them. So someone shout out some variables that we can use.
Okay, so we could use F and C. F for chefs, C for customers.
It doesn't really matter either way. Well, yeah, F and C. Sounds good. So let's define our variables. Write it down in your notes. I need to somehow convert an equation that deals with chefs and customers. Generally speaking, you're going to either have an equation for chefs, an equation for customers, or an equation that combines both of them. I mean, those are the only options. So let's go ahead and, I would say like 80% of the time, F and C are going to be combined in the same equation. F and C are going to be defined in the same equation. So what is this category going to be? Sometimes the category is money, or number of legs, or total number of animals, or anything. What are the two categories going to be, Charles?
Number of people.
Number of people, and then what would the other category be?
Number of food items.
That's a good guess, but it's not quite right. Anyone else want to take a guess? Jade?
How many chefs there were?
So chefs is already right, or sorry, F is for chefs. So we have chefs right there, so that's not a category, but good guess. Emma?
Sushi?
What do you mean by sushi?
Like the rolls?
Okay, so what would this category be specifically?
Sushi rolls, right? Or just...
Not quite, but you're the closest one to the answer for the category. Jade again?
The number of rolls?
Number of what type of rolls?
Regular?
Radical shoes?
Okay, so Charles kind of has the answer. This one is going to be regular rolls, and this one is going to be vegetarian rolls. There are two categories of rolls. There's vegetarian and regular. So that's going to be kind of the two categories of equations. And we know that we're going to be combining F and C inside of that equation. I will point out that I probably should have done example 5 before example 4 because example 5 is a lot easier. Example 4 is the hardest problem I could find. All right, so
Is this gonna be on the final?
yes, this is, yeah, word problems.
How many questions are usually on the final for algebra?
Usually between 30 and 40.
Not that much.
The final should take you about an hour if you know what you're doing. So that means the people that haven't studied will take the full 2 hours. And if you really, really know what you're doing, you can probably finish in half an hour.
Challenge accepted.
All right. So this is how a restaurant works. Chefs make the food. Customers eat the food.
No. No. I didn't
That means whenever I have regular rolls, if I'm talking about this regular category, the number of chefs should be a positive amount because I'm making regular rolls, and then customers will be eating those rolls, and you'll be subtracting those regular rolls.
So,
Which means if I come back here into this equation, I'm going to have some positive number and some negative number here, and the number of rolls that are left uneaten is going to be this number right here because I'm going to have that positive number that were made by the chefs. I'm going to eat the rolls, and then this is the number that's uneaten.
so don't we know how many were not eaten already in the equation?
Yeah, so how many regular rolls were uneaten? Go for it. What?
8.
8. And how many vegetarian rolls were left uneaten, Charles? 4. But now we have to somehow combine these two equations and put some coefficient out here. We have a lot of numbers out here, 10, 12, 4, 3, that we haven't used. We've used the 4 and the 8. The 8 and the 4 we haven't used. So we need to use the 10, 12, 3, and 4 as the coefficients for these two equations. So for the regular rolls, how many are the chefs making? F stands for chefs. Ulysses. 10, there it is. How many are customers eating? How many am I going to be subtracting for each customer? Right here. How many am I going to be subtracting for each customer for regular rolls? Customers eat how many regular rolls, Jade? Jade?
Oh, 3?
Yeah, each customer is eating 3 regular rolls. Perfect. Someone do the entire second equation now. How many vegetarian rolls are the chefs making, and how many are going to be eaten? Esha.
12 F minus 4C.
There it is. You have now set up your two equations, and that is the hard part. Like, once you set up the equations, we know how to do elimination. We know how to do substitution. It's still kind of hard, but, the hardest part is getting those equations set up. Wyatt.
I think I know the next part.
All right, go for it.
So I would multiply each equation. No, I'd multiply the top equation by 4 and the bottom equation by 3. So you get equal coefficients for the C variable of the customer.
All right, we're trying to eliminate that C variable.
Yes.
Question, Charles?
Could you like add the whole equation by something?
If you add it on both sides, then yeah.
Yeah, so you can add the whole entire top equation by 2 without work.
Yeah.
That would mean I'd have a 2 right here and then a 10 right here.
Yeah.
8 times
I don't see how that
And then
helps you
10
eliminate
would
it.
be a 12.
Oh, 10F. So you can't just add, you could add 2F
Oh.
to both sides, but then you have another F over on this side.
Okay.
Yeah, it's a good idea, but it didn't quite work out. Yeah, so let's go ahead and multiply the entire top equation by 4, entire bottom equation by 3. Let's do some colors. So, Wyatt, can you read off the top equation then?
Yes. 40F minus 12C equals 32.
And I need another volunteer to read off the bottom equation. Who needs? Yeah, Ugo.
36F minus 12C equals 12.
Thank you. Yeah, there they are. Well, now I have matching variables, so I need to either add or subtract these somehow to eliminate that C variable, that customer's variable. Ulysses?
Subtract.
Subtract, let's do it. So when I subtract, what I'm really doing is I'm subtracting every single term. I'm subtracting this term, I'm subtracting this term, ooh, double negative. I'm subtracting this term. So whenever I subtract, make sure you're doing it for each of those terms.
Wait, so Mr. Sandell,
Yes, Emma.
how'd you get 36?
36F.
Yeah.
So I'm doing 3 times 12, and 3 times 12 is 36. Yeah, 3 is being multiplied by that entire equation. Question, or you got it?
No, I don't have it. I just have a question.
Yes.
Why is it a double negative? Like, shouldn't you add because it's minus 12 and minus 12, so same sign subtract? Oh, same. Never mind.
I'm glad that you figured out on your own. That's awesome. Okay, so I'm subtracting each of these terms. Double negative means that's really a positive. Wyatt, talk to us.
After that, you'd have 4F equals 20. And then you would divide by 4 on each side.
All right, let's do that. Divide by 4, and I get...
F equals 5. And then you'll...
I'll let someone else do that, but thank you. All right, let's make sure that everyone understands what's going on. Again, we're subtracting each of these terms because I had double negative 12s. I guess it was right there. When I have the same sign, I need to subtract. When I subtract every single term. Since I have a double negative, that's a positive. 40 minus 36 is 4. Negative 12 plus 12 is nothing. 32 minus 12 is 20. So we got the equation 4F is equal to 20. After that, we divide both sides by 4, and we get F is equal to 5, which means what? What does F equals 5 mean in the context of the equation, or in the problem? What does it mean in the real world? If you come up and say, hey, F is equal to 5, they're going to be like, what are you talking about? Emma, talk to us.
There were 5 chefs. There were 5 chefs and 5, or just 5 chefs were in the radical sushi on Tuesday.
Perfect. I love, like, everything that you said was amazing. Not only were there 5 chefs, there were 5 chefs in Radical Sushi on Tuesday. That's what this tiny little bit of information means. But notice it's asking for not only chefs, but also customers. So after finding F is equal to 5, we need to do what, Ulysses?
Like plug in 5 for F on one of the equations.
Perfect. Which one do you want to choose? Top equation or bottom equation?
Top.
All right, so I have now 10 times 5 minus 3c is equal to 8. Did you want to keep going, Ulysses?
Yeah. So it would be 50 minus 3c equals 8.
All right. Ulysses, calling someone to continue on for you.
You would subtract 50 on both sides.
What is our new equation after doing that?
After you do that, you get negative 3c equals negative 42.
It is indeed negative 42. Perfect. And then, Emma, you can call on someone else to do the next step.
Why, I guess?
After that, you divide by negative 3 on both sides. And then your final equation would be C equals positive 14.
There it is.
Positive because you're dividing a negative by negative.
I like how you explained that.
That means that there were 5 chefs and 14 customers in Radical Sushi on Tuesday.
Radical
Well,
sushi.
well said. Yes.
Radical Sushi.
Thank you.
Radical sushi.
That was a hard problem. So if you guys are at all confused, that is okay. Example 5 will hopefully make it seem like some of these problems are a little bit easier.
I just don't
Yeah.
know how to write algebra.
That's the hardest part.
Yeah.
I look at the thingy and I'm just like words and numbers don't go together.
I'm looking at example 5 right now, and I'm wondering, do Jade's legs count?
Yeah, I was thinking about that too when writing this problem. Jade does not count. I should have said 32, the total of 32 farm animals, and I consider Jade not a farm animal. And then a total of 104 legs, and I should have said 104 farm animal legs, to be more specific. You're right, Eamon. But we're going to assume I'm only talking about the chickens and cows. So can I get a quiet raised hand or actually read all of example 5, Emma?
Jade owns a farm with only chickens and cows. There are a total of 32 farm animals on her farm and a total of 104 legs. How many chicken and how many cows are there on Jade's farm?
Perfect. All right, so someone identify the variables and make a letter for that variable. Charles.
The chickens and the cows are variables.
Perfect. So what should our variable letters be?
Let's see.
Do K for chicken and C for cow.
K for chicken, C for cow. So those are our variables. So somehow I'm probably going to have some sort of C and K combined, some sort of C and K combined. I just now have to figure out the categories of each of those equations. Looks like Charles is ready to go, but I'm going to let everyone else think about it as well. What are the 2 categories that I have? Esha.
Well, you need to figure out, I think it'd be easiest to figure out how many cows there are and how many chickens there are. So then we could do,
More cows.
something C plus something K equals 104 legs.
Oh, okay, so this should be like the leg equation then. We'll say the yellow is our leg equation. And we're definitely, you're correct, we're going to somehow add them and we're going to get 104 legs. So now that tricky bit is what should our coefficients be in front of those variables? And Esha, you can call on someone or you can figure it out on your own.
Kira. Well, chickens have 2 legs and cows have 4 legs.
Wrong ones.
Ah, you're right.
That could be.
Bananas are yellow and apples are green.
Sometimes, yeah.
But if you do 2C plus 4K, you won't get 104. Yeah.
No, but let's see here.
You have defined your first equation though. That is just an equation that we're going to be using in order to do elimination or substitution. So that's our leg equation. What should our second category be and how do I set up that equation? What?
Your second category would be animals, like farm animals.
Animals, perfect. And then Larissa,
The
okay,
right side of the equal sign, it would be 32 because there are 32 farm animals.
perfect.
I say 2K. I say
And I
32.
don't know what to do in front of the C or the K.
I say it's just gonna be all cows.
So I guess this is where it helps to really formally define your variables. K is not just chickens, it's the number of chickens. Does everyone agree that K is the number of chickens?
Yeah.
C is the number of cows, and this is the number of animals, so I don't need to do anything. It's just add up the C, add up the K's, that's the total number of animals, and the total number of animals is 32. Charles?
So then you would multiply the bottom equation by 2.
Oh yeah, you're already trying to do elimination? Yeah, okay, so I want to make sure that before we start doing elimination, are there any questions on how to set up that equation? Or those 2 equations? Question, Eamon?
Can we have 25 Can we have 25 cows?
We could. Is that your guess for the answer?
I mean, 25 cows and then 2 chickens would make sense.
25 cows and 2 chickens. Let's come back and see if that's right. All right, so let's follow with Charles's math. He says multiply this entire bottom equation by 2, so 2, I can just do like this, 2, 2, and this is now not 32, it's 64. I multiplied every single variable by 2. Is that 2? I can write it underneath as well.
Assuming that
2C
25
plus
cows.
2K is equal to 32. Okay, so we're done setting up our equations. We're done in terms of converting our word problem into an equation. Now we're purely looking at these two equations saying, how do we solve? And Charles said, hey, we could use elimination if I multiply that bottom equation by 2. So that's what we're doing. We're multiplying the bottom equation on the left and right by 2. So 2 times c is 2c, 2 times k is 2k, 2 times 32 is 64. And now we can kind of ignore this blue equation, and we're only dealing with the yellow and green equation, and somehow we're going to combine those to eliminate one of these variables. What am I going to do? Am I going to...
64 on the right. Oh, you just added them.
I'm not showing my work, am I? So I'm multiplying everything by 2.
Right.
Multiplying that by 2, multiplying this by 2, and multiplying both sides of the equation by 2. All right, so from here, what am I doing? Am I adding the yellow and green? Am I subtracting the yellow and green? Larissa? Subtracting, yes. So that means I'm going to be doing a minus sign, and a minus sign. Larissa, can you do that for us? So just looking at the yellow and the green now. 2c
2c equals negative 30 or negative 20.
Oh, so you're looking at 104 minus 64.
That would be 20.
How much do I have to add to 60 to get to 100? 60 plus,
50
close.
something?
Just 40.
Oh. Okay.
All right, and Charles,
40 divided by 2 is 20, so c equals 20.
divide both sides by 2, and c therefore is equal to 20. We're almost done. We're almost done with the notes. I know these were kind of some long notes. That's what happens with word problems. We know that there are a total of 20 cows. C stands for cows. So 20 cows. You can write down cows down here to remind you.
Oh.
That means what? How do I find chickens? Kira?
Okay, well, you could just go 20 plus k.
Oh, you're doing the blue equation right here?
Yeah.
Okay.
Equals 32, which is just 12.
20 plus k is equal to 32. Subtract 20 on both sides. Minus 20. Oh, that's a bad 2. Minus 20. Minus 20. And k is equal to 12. And 12 is k. K is chickens. Chickens. Nice. So 20 cows and 12 chickens on Jade's farm. Questions, Kira?
Are we supposed to solve how many legs there are or whatever?
I mean, we know that there's 104 legs. You can find how many cow legs there are, but it's only asking how many cows, not how many cow legs.
Okay.
I could just multiply by 4, right? There's 80 cow legs. All right. That concludes these notes. Everyone give me a fist of 5 for our objective. Create and, that's the hard word, right? Create and then solve a system of linear equations from a real life problem. I'm seeing 3 and a half-ish, 3, 3.5, 5, and 3. All right, yeah, so hopefully doing the homework will help us. Please be using those hints on Khan Academy if you have no idea what's going on or if you just need those hints. Yeah, that concludes the lesson.